Okay, so we've done systems of 2 equations and 2 variables. Now let's look at systems of 3 equations and 3 variables. This is a little bit more complicated, but your goal is to be smart and make it look like one of the other problems through not a lot of work, but a little intuition and a little work. Okay, so the problem is we know what we can do if we have 2 equations and 2 variables. It's not that difficult. So your goal is to find a way to combine 2 sets, either the first and second, the first and third, or the second and third, in order to eliminate one variable. If you have 2 sets and you eliminate the same variable, you now have 2 new equations and just 2 variables, and you can use your skills from the first half. So the first thing you want to look at is one of these have a 1 in front of them? Usually that's the easiest one to work with the exception of if there's a missing term entirely, but we'll worry about that later. So notice if we add equation 2 and equation 3, the z will cancel out. So let's go ahead and try that. What happens when I add them? I get 2x plus x is 3x plus 2y. My z's cancel and it's equal to 4. So now I have just one equation in terms of x and y equal to a number. But I need 2 of them. So how am I going to do that? I need to find a way to get rid of z using a different combination. So let's multiply 6 times equation 2. That would be 12x plus 6y minus 6z equals 12. Now why would I do that? Notice that there's a 6z up in equation 1, so that when I add this to equation 1, what happens? My z's cancel and I get 15x plus 15y equals 15, which is nice and convenient. We can divide them all by 15, so x plus y equals 1. So we've got 3x plus 2y equals 4. This is equation 4, and now we have this equation 5. Now I can use these 2 equations to figure out what x and y are. So what I'm going to do is take equation 5 and multiply it by negative 2. So negative 2x minus 2y equals negative 2. And I'm going to combine this with my equation 4. Now notice when I add these, 3x minus 2x is just x. The y's cancel. 4 minus 2 is 2. So I immediately find out that x is 2. And I can use that to find y. I know x plus y equals 1 from equation 5. That means 2 plus y equals 1. So subtract 2 to the other side, y is negative 1. And lastly, I can take both of these and figure out something for z. So x plus y plus z equals 2. If I plug x and y in, z will be the only one left. 2 plus negative 1 plus z equals 2. That's 1 plus z equals 2, so z is 1. What does that mean? I have a solution for x, for y, for z. So just like before, I put it in an ordered pair, but I have now 3 numbers in my ordered pair. So I'm not going to fully solve number 2, but I do want to talk about it. So look at 2 on page 4. It's negative x plus 2y minus 4z equals 6. 3x plus 5y plus 8z equals 13. And 5x minus 3y plus 2z equals negative 18. You might be asking yourself, how did I figure out that I wanted to use z? It just really lined up here, right? But I could have used x as well. It's easy to turn 1x into 2 or 3. That could have worked. I could have even used y, because these are both y's. I just would have to multiply by a negative, and then multiply 1 by 9. So all of them would have been fine options. It's just that z had an opposite sign already, so that's the one I went with. Now let's look at number 2. X has a 1 in front of it, so it's going to be easy to max up the x's with 3x or 5x. Even z would be easy because 2, 4, and 8 are very easy to turn into each other. However, what do you notice about y? Y has a 2, a 3, and a 5. It's hard to turn a 2 into a 3 or a 2 into a 5 without messing with both equations. So if you're going to do this, eliminate x or z first. Do not do y. While it's possible to do y, it will make your life much harder if you go for y. You're going to be multiplying both equations. And so after this, there's the word problem section. I have an exact problem from the business algebra section that is the same as yours. So I'm going to move the business algebra video into the playlist for you guys as well, right after this one, so you can see how the parabola word problem will work. And so that will be all of them for today, and I will talk to you guys again on Thursday.